Hi Dragons, this is an example of writing an equation from a graph. You'll have about 4 of these to do in class today, give you about 30 minutes for these. As you're writing equations from graphs, please make sure you keep in mind your 4 steps that I asked you to write in your composition books. Identify the y-intercept, identify at least 2 points on the line, draw your rise and run slope triangle, and label the units of the slope triangle, including the directions. So as we take a look at this graph right here, we're looking for some points that intersect the horizontal and vertical grid very cleanly, such as 2, 1 and 3, 3. You just need 2 of them, and so as we come along here, the first thing we were asked to do is to identify the y-intercept. So as I identify this y-intercept, this is 0, -3. Identify at least 2 points on the line. Well, I've done more than 2. And we're going to draw our rise and run triangle next. Again, pick any 2 points, and we'll draw our rise and run triangle. There is one right there. You can do this multiple times. Between any 2 points on the line, the ratio will remain consistent. Alright, so we're going to label the units of the slope triangle, including directions. And what that means is when we talk about rise, we're going up. So if we go up, that is a positive rise. And if we go down, that is a negative rise. Think of going up and down an elevator. And as we go to the right, that is going to be a positive run. And if we go to the left, that's going to be a negative run. If you notice, these follow the x and y axis. The numbers to the right on the x-axis are your positives, to the left are negatives. So your rise and run directions are the same as your x and y axis. So let's go back to one of these rise and run slope triangles. We're going to go up, so my rise is going to be a positive 1, 2 units, and my run is going to go to the right, so that's going to be a positive 1. So we followed the 4 steps. Now let's answer these questions. Draw and label a slope triangle on the graph. Did that. Label the y-intercept of the graph, and we identified that. And if you want to put it right here just for reference, we can, and write the equation for this function. So as we take a look at this, we remember for lines, our general equation or our slope-intercept form is y equals mx plus b, where m is the slope and b is my y-intercept. So as we come over here and look at our picture, we look at our slope. Its rise is up 2 and right 1. So my slope is going to be 2 over 1, or 2, and so we're going to plug in a 2 for my slope. Y equals 2, need our input, so write down the x, and now we'll look over here at my graph. It crosses the y-intercept at -3, and so we will show that negative by saying -3. So my equation is y equals 2x minus 3. Now please, if you want to, I would strongly encourage you to take your calculator, go to your y equal button, type in 2x minus 3, press graph, and that graph on your calculator should look exactly like the one that we have right here. It's a quick, easy check. I suggest that you do that. So we're going to label the x-intercept on the graph. As we take a look at this one right here, this is halfway between 1 and 2, so my x-intercept is going to be 1.5, 0. You remember what the x-intercept is also called? It's called the 0. So the coordinates of the 0, actually I should have written that in the blank that I provided, so I'm just going to put an arrow right there because I'm kind of lazy. Alright, so is this a function? Should you do your vertical line test? Take your pencil, touching once, touching once, touching once, always touching once. This is a function. Explain, passes the vertical line test. Is this graph continuous or discrete? Now, if you look at this graph right here, you think that it ends here and here, but this is just like your calculator screen. I want you to realize that because of the limitations of a piece of paper and of a calculator screen, this actually does go on forever. So go ahead and put your little arrowheads on each side, and because I can do this in one continuous motion forever, this is going to be continuous. And an explanation of why is this continuous. We can draw with one continuous motion. Now, if this has arrowheads on each side, we're not going to be able to put this in our box. So our domain and range, as we take a look at this, can't put any sides of the box on this because this is going up and right forever and this is going down and left forever. So I can't put a top or a bottom or a left and a right side on this. So my domain is going to be all real numbers, and the range all real numbers. Now, real numbers sometimes is, in mathematics, is a double-stemmed capital R. So when you see this, you need to think real numbers. All right, what is the input value when the output is 8? Input value is the x. So it's asking, hey, whenever you have an output, which is a y, whenever the y is 8, what is the input? Here's where your calculator comes in really nice. So as we come over here and type in our equation, we have 2x minus 3. And let's go to our table and let's see. If I have an output of 8, you notice it doesn't appear on my screen. I have no output of 8. But you notice that 8 is between 7 and 9, halfway. And so over here, we might want to say that that's between 5 and 6, which is 5.5. We could easily check that by taking a piece of paper. Wish I had more here. We come over here and say, okay, when I have y equals 2x minus 3, if my y is 8, what is my x? You would need to solve for x. And hopefully you're comfortable doing that. There's my 0 pair. I get 11 is equal to 2x, divide by my coefficient, and 11, half of 11 is 5.5. So, what is the input when the output is 8? I check it, and indeed it is 5.5. Do the next problem, what is the output? So what is the y value whenever the input, or the x, is -4? Calculator will do this because I know I'm going to have an input of -4. It's right there, -4. Input gives me an output of -11. That's a lot easier when they give us the x. Alright, explain how this function compares to its parent. If you remember, the parent function is the most basic. The parent linear function is y equals x. The slope is 1, the y-intercept is 0. So, if I come over here and superimpose on my graph the parent, you can see the parent always goes through the origin, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, -1, -1, -2, -2, -3, -3, etc. Now, because I like you guys, I'm going to go ahead and put the parent on here. And now let's compare the green line, which is the parent, to the line that we have given to us. If you notice, the y-intercept has, from the parent, has gone down 1, 2, 3. So it has translated down 3 units. And the other question you need to ask yourself, the line up here, is it more steep or is it flatter compared to the parent? So if the parent was here, it looks like this new line has gotten steeper. And so we will put the word steeper. Now, if you want to get really technical, you can say steeper by a factor of, And if you notice, this has a slope of 2, but my parent has a slope of 1. So what do I multiply 1 by to get 2? You multiply it by 2. So it's steeper. This by a factor of 2 is optional, but it sure would be nice if you had that. And that's how you do graphs to equations.